Welcome to AP Computer Science. This is assignment 6.00. The first assignment is to write a recursive method to compute a Fibonacci series. Start at a user-supplied starting point and continue 10 places. Okay, the first thing you need to do, you need to figure out how the Fibonacci sequence is made up. How is it recursive? So what happens is your next number is found by adding up the two numbers before it. So we start off with 0 and 1, and 1 is equal to 0 plus 1. 2 is equal to 1 plus 1, right? 3 is equal to 1 plus 2. 5 is equal to 2 plus 3. 8 is equal to 3 plus 5. 13 is equal to 5 plus 8. 21 is equal to 8 plus 13. And 34 is equal to 13 plus 21. So how would you do that with a program? This is what you have to figure out in order to build this thing. Make our class, public class, Fibonacci series. And the first thing we're going to do is we're going to establish our array. Okay, we're going to take whatever the user declares as integer n, and we're going to give it 10 cases. So we're going to start at the 0 case, fib n, put a comma in between, then add 1 to it, 2 to it, all the way up to adding 9 to it. That'll give us 10. The first 10 in the series, beginning at n. Then we're going to print out whatever this series will be. We'll print out our array. So what's the actual Fibonacci recursion? So we're going to start out with fib here. We're declaring it here, even though we're running it here, see? But it's not important. So we establish our integer n to begin our array. And here's our lowest case, n less than or equal to 2. And we're going to return 1. Now, I know that 0 and 1 are particular issues where they don't fit the series and they're established. So if you want to do an if-else statement in here and say if it's 0, then return 0, fine. But I'm thinking, you don't have to go through all that. We'll just have it return 1 if n is less than or equal to 2. Okay? So that's your base case. Because this is a recursion, right? Recursion has to have a base case. In any of those cases, you're going to return a 1. Otherwise, what? You're going to return Fibonacci n minus 1 plus Fibonacci n minus 2. So how does that work? This means that you're going to have to build this because, say, n is equal to 10. It can't run it until it figures out what n to the 9th is, n to the 7th, n to the 6th, n to the 5. So it's running this almost like a loop until it comes to the lowest case, being 2, right? So then it's going to back up from there. It's going to push out the answers, and it's finally going to be able to do this. So before we close this, we'll compile this, and it's fine. So now let's run this and see what it looks like. I'm going to right-click this. I click New Fibonacci Series, and it says Name of Instance Fibonacci 2. It's OK. So here it is, right down here. I'll right-click this, and I'll run it. So what number do I want to put in here? Let's say I want to put in 10. So I'll click OK. So return the answer of 55. That's how it works. So it worked. So is it Is the 10th series 55? It sure is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Assignment 2. Write a recursive method, revdigs, that outputs its integer parameter with the digits reversed. For example, revdig 147 outputs 741. You will have to use your modulus operator in integer division. So let's call this particular class reverser. What we're going to do is we're going to take any particular digit and we're going to turn it into a string. So here we go. What we're going to do is take this digit. What we're going to do is we're going to take this and turn it into an array. Any particular digit. So we're going to load up this array with whatever this number is backwards. So that means we're going to have to come up with the smallest case. The smallest case would be whatever the single digit is. So the smallest case is the number less than 10. Okay? So then you're going to print out the numbers one by one in the string that you've created, which are called reverse digits. So your else statement is going to look like this. You're going to take whatever the number is and divide it by 10, and whatever that remainder is, you're going to put in given. Remember, the modulo is division, and what you're coming up with is the remainder. So when it finally gets to the 0 case, it's going to print it out. And so it's going to divide it by 10 over and over again until it gets to the base case. So that's what it's going to look like. Okay? So let's compile this. It compiled fine. Let's run this. Okay, we're running this. So I'm going to put in here some sequence. 2, 5, 6, 7, 8. Let's see if it reverses it. There it is, 8, 7, 6, 5, 2. So it works. That's exercise 2.